My name is Aaliyah Williams, and the title of my project is The Effect of Cadmium Chloride on the Cardiac Development of Zebrafish Embryos. The purpose of my experiment is to investigate if there are morphological and functional defects of the zebrafish heart due to varying concentrations of exposure to the environmental toxicant cadmium in the early stages of development. I hypothesized that if zebrafish embryos are exposed to varying concentrations of cadmium, then their hearts will exhibit developmental defects. Zebrafish treated with higher concentrations of cadmium will have a higher heart rate and a larger ratio of distance between sinus venosus and bulbous arteriosus heart chambers due to body length of the zebrafish embryo. During the embryogenesis of zebrafish, the heart is the first organ to fully develop and function. Even though the heart is able to function and is developed, it will not be essential to the embryo's ability to live until after several days. This is because the connection of circulation has not developed yet, preventing full blood circulation. A regular resting heartbeat is usually between 60 to 90 beats per minute for humans, but for zebrafish, a heart rate is usually between 120 to 180 beats per minute, which is relatively similar to humans. The zebrafish is an ideal model to study the toxic effects of cadmium on heart development. Cadmium is a toxic chemical that is non-essential to biological processes, and there is usually low levels of exposure in our environment. But there are still multiple ways one is exposed to cadmium, making the investigation of it important. Upon experimentation, the results were recorded and analyzed. The mortality rate of the zebrafish embryos were recorded in Figure 3 according to their hours post-fertilization and amount of cadmium treatment. The highest percent mortality rate was the 1.0 milligrams per liter cadmium chloride treatment group, and the lowest was the control treatment group. Figure 1 visually shows the heartbeats per minute recorded at 48 hours post-fertilization for the different treatment groups. Looking at the graph, the heart rate of the zebrafish embryos tended to increase as cadmium concentration also increased. Figure 2 visually shows the ratios of the distance between the sinus venosus and bulbous arteriosus of the heart to its body. The graph shows a tendency of a higher ratio for the zebrafish embryos treated with higher concentrations of cadmium chloride. To conclude, if zebrafish embryos are treated with varying concentrations of cadmium chloride solution, then their hearts will abnormally develop. The ratio of the distance between sinus venosus and bulbous arteriosus of the heart and body length will be higher in embryos treated with higher amounts of cadmium chloride compared with the control group of 0 milligrams per liter cadmium chloride. It was also predicted that the heart rate of the embryos would be concentration dependent, resulting in higher heart rates for larger concentration treatment of cadmium chloride. Based on experimentation results, the original hypothesis was supported because as the cadmium chloride concentration increased, so did the heart rate of the zebrafish embryos. The ratio of sinus venosas and bulbous arteriosus of the heart compared to the body length also increased as concentrations increased, showing a possible morphological defect. The implications of this experiment involve exposing specific effects toxic heavy metals such as cadmium can not only have in zebrafish but possibly in humans due to our similarities. Discovering a causal relationship between cardiovascular disease and cadmium exposure is very useful because it may explain sudden onsets of cardiovascular disease cases, and it can be used to even further understand the drastic effects of cadmium. In order to improve this experiment, more trials with more zebrafish embryos would have to be used due to the lack of quantity of zebrafish due to their high death rate within this experiment, causing redesign of the experiment throughout the process. Also, further research could include measuring the heart development of an actual fully developed zebrafish and its heart function so the full effects of cadmium can be observed.